Today I'm borrowing Bosch's workshop to fix a really common problem on EVs that's actually quite simple to fix, but you do need access to advanced software to make that possible. Let's face it, EVs are with us whether we like them or not, and I often get asked about a particular aspect of EV ownership.
What is the most common problem with EV brakes?
Do EV brakes still need maintenance?
Why do EV brakes get so rusty?
How do you clean the rust off EV brakes?
How often do EV brakes need changing?
How easy is it to change EV brakes?
And with any luck, I might actually answer some of those questions in this video.
Ed, why are you in a bath?
Ed, why are you in a bath?
Ed, why are you in a bath?
Why are you in a bath?
And why are you in a bath, Ed?
Even the one about the bath. One advantage of EVs is that because of regenerative braking, a fair chunk of the kinetic energy is scavenged back into the battery rather than turning it into heat as with ICE vehicles. So more of the original stored energy gets used, increasing the range of the vehicle per refill. But this can lead to another problem. The brakes don't get used nearly as much. So although they last longer than on an ICE car, the lack of use can also mean they corrode more quickly thanks to the salts on the road. As with many modern cars, to get the rusty discs off to clean or change them, one needs to ask the car nicely to back off the parking or emergency brake through a VCI or vehicle communication interface. Back in 1980, GM introduced their first data link on their Cadillac Eldorado and Seville models. Then in 1994, the OBDII port was introduced and became mandatory on all vehicles in the USA from 1996 models onwards. So to diagnose most cars on the road, you would plug something like this KTS590 into the OBDII port and use a laptop like the DCU220 with some diagnostic software like this Easy Tronic to scan for error codes, inspect live data, force a DPF regen, or particularly on later vehicles, adjust some of the user settings. But progress is relentless, and soon many cars will be changing over to a central computer, known as software-defined vehicles. In 2012, with the launch of their Model S, Tesla launched the first mass-produced software-defined vehicle, which also came with over-the-air updates. Other manufacturers, particularly the Germans, have also been dabbling with this kind of technology for a while now, and soon they too will be launching their SDV vehicles, any minute now. The first major difference between SOVD or Service Oriented Vehicle Diagnostics, i.e. communicating with a software-defined vehicle and looking up error codes via an OBDII socket, is how an engineer approaches a repair and how their tech actually talks to the car's computer. So instead of communicating with modules via CAN through a now commonplace OBDII port, technicians can actually connect directly to the car's computer through a data cable to an Ethernet port. For this job, I'm going to be using a Bosch KTS590 with a special Tesla cable kit. So on my Range Rover, if I suspected an issue with the electric park brake, for example, I would plug my vehicle communication interface into the OBDII port, go for the diagnostics, and once my software is talking to the car, it would list all of the available modules. And I could pick the EPB module and get a list of errors, or in this case, just the one. And with EV Tronic on diagnostic level, I could potentially look up known faults or experience-based repair, but the car isn't going to give me any more help as to what is actually wrong with it or how to fix it. On the other hand, with the Tesla, I connect to the data socket with the special cable and also power my VCI with the 12-volt accessory socket. Now my software can communicate directly to the central computer of this software-defined vehicle, and the Tesla will then give me a complete list of executable tasks from the vehicle. Now you can see here on the screen you've got a different colour, it's a slightly darker blue, and that's because it is a software-defined vehicle. So I'm now going to click on there, and then I just put in my EPB. So you can see here you've got 4 kind of actual error messages, if you like, and you can see there's quite a nice little description in the paragraphs here as to exactly what's going on. And then you can also see down here you've got this little yellow one here, and that is just kind of like just a warning, if you like, just to let me know that there's actually a warning on the dashboard of the car as well. So it's just so informative. But then if I click on this information here, then you can see then you get a load more information down there. If I click on that, like so, and it's just grabbing the very latest information from the internet while it does a little bit of thinking. And of course, that's one of the advantages. This is updated, sort of all the time. So literally, whenever you're looking at this, you'll have the exact correct information. So then you can see, got this little mind map. So some more information here on this side. There's like a little mind map here. And this is kind of like really the process you go through to try and resolve this problem. And obviously it prioritizes stuff. So you've just got this nice long list. If I ignore that list completely, I'll just click on that little plus down there. So that gives me some sort of further information. But if I then click on the words itself, you can then see that it's suggesting that basically it's a problem with the wiring loom. To go through, it tells me all the things it could be and how to resolve that, what to look for, which is all very handy. And of course it's quite clever because it actually knows, because I've actually unplugged the plug that goes onto the electric park brake just to try and generate this error. But basically it's such a great way to work. So even though it's a little bit intimidating, this whole new way of working, this is going to be so much better, and it is absolutely the future. Until recently, you would have needed to buy Tesla Toolbox to do a job like this, which used to be thousands, and even though it's now cheaper, it can only be used on a Tesla. Thankfully, Bosch's ESI tronic software now includes the Bosch Tesla Toolbox with its ability to diagnose and work on Teslas, alongside all of the other manufacturers and models that have always been accessible via ESI tronic since the 90s. But you're actually benefiting from 50 years of technical information, knowledge and experience from Bosch. It's also worth mentioning that the ESI tronic software is actually available in 3 tiers, giving you increasing levels of functionality: Diagnostics, Advanced and Master. So to change the brakes on the Range Rover, I'd have to find the electric park brake function and then tick the box to wind back the calipers. So I literally just do that, go down to there and go. And then you can hear the handbrake is now actually being wound off, so I can now do the brake servicing nice and simple. On a newer Tesla, there are over 2,500 listings in the data stream. On this one, it's about 350, and you can see we've got tons and tons and tons of different sort of bits we could be looking at. But either way, I need to use the search function to filter down to what I'm actually looking for. I need to chat with the central computer and tell the car I want to fix the brakes. So I start with the repair manual rather than the diagnostics. The car shows me the process, then I follow those instructions. It's so much better than trying to back probe the live CAN information and trying to narrow down what you're actually looking for. Thank you, John. Lovely. Smashing. The diagnostic level of ESI tronic allows me to diagnose problems and see error codes. It also provides the Tesla Diagnostic secure gateway access with one master password, and a library of common problems with experience-based repair. Basically, any of the vehicle interactions you need to diagnose and service a vehicle. Then the advanced package gives me access to guided troubleshooting, the workshop manual, and a copy of OEM repair information with the ability to filter the data so it's no longer a case of looking for a needle in a haystack. Finally, the Master package gives me access to service information like maintenance schedules and even more wiring diagrams. The kind of information a tech would get by paying extra for a standalone automotive service and maintenance technical data provider. Everyone else charges extra for service schedules. ESI tronic includes them. Go on then, right, back to Bosch. There is actually a further on-demand level of support called Bosch Remote Diagnostic Service for when you get really stuck. Now, there is a French car company that shall not be named that has a bit of a problem with its AdBlue systems. Now, you can end up replacing all kinds of bits, including all the electronic boxes and stuff, and it won't actually solve the problem because it's a software issue. But ESI tronic would allow you to download the correct software or the upgrade and then actually upgrade the unit so it actually works properly. It's really great to have all this information for so many vehicles in one solution. Right, now go on, crack on. Now, a really important point, obviously in the workshop manual, the first thing it wants us to do is obviously lift the vehicle via very specific positions on the car. You can see these green little patches here, and obviously a close up there, and you can see there's a little hole in the middle of that kind of green triangle, and that is for these. Now, they're little pucks. It's quite a simple product. It's like a big lump of rubber, and you can see it's got like a little O-ring in there, and the idea of the O-ring, of course, is then to hold it in position while you then maneuver the ramp into place. But obviously it's very important you do this because, of course, it's quite a heavy car, probably over a couple of tons, and obviously you want to make sure that when you're lifting up on those rails you're not squishing anything you shouldn't, and that's exactly what these are for. And these are now available as a set of 4 from the greasejunkie.com store. Right then, so we've now lifted the car up using the special pucks in the special positions, and so the car is now ready for the next stage in the instructions, which is very simply just to actually put the electric park brake, or the EPB, into service mode. And what that's going to do is actually wind the electric motor back, so there's a little rod that goes away from the piston, which means they can then be parted to get out the pads, and we can change the discs. So what I have to do is just click on here like so. I can then go down to service tasks, just like so, and then service position for electric park brake. And then I want to basically go into maintenance position, so I just press that. Obviously, I've got to have my foot on the brake. And theoretically, it's going to think about it for a bit. Like that. Winds for a long time. Winds for a very long time. It just goes to show how warm the pads are. There we are, good now. So now that's set, we're all happy. I can now then start to take everything apart and then start changing the brakes. So then, with the wheels off and the EPB wound back, we can now actually replace or clean our rusty brakes. But in the case of this particular 3, these discs are actually in pretty good nick, but the pads are very worn for an EV with only 130,000 miles on the clock. And it turns out that the owner, Richard, has got a bit enthusiastic with it on a racetrack. His Model 3 daily driver has managed about 233,000 miles, and the pads are in better nick than this and still have plenty of life left in them. Now, on the older Model S and X models, the discs have been known to rust and pit quite badly as they get so little use thanks to the regen, but the later cars like this have some software tweaks that paradoxically give the brakes a little bit more use so they last longer. So compared to an ICE car like my Range Rover, where I probably have to change the pads every 30 to 50,000 miles, an unraced EV will probably manage 250,000 miles. Now that's quite a saving on parts and servicing and a lot less brake dust in the atmosphere. Now these discs probably wouldn't actually fail an MOT, but as I've got this far, I'm going to change the discs and pads anyway, because it's a nice thing to do. And part of the deal of borrowing the car. Right then, starting with our front brakes here, you can see the discs themselves, you know, they're pretty rusty, they're not terrible. When you compare them with, say, this nice brand new one, you can see that there isn't actually that much difference. There's definitely no difference in the thickness particularly, and obviously you can get this protective coating on this one, which is obviously ideal. The ideal is to try and stop some of that corrosion over time. But anyway, it's definitely worth changing the discs anyway, because why not? I don't know how warped they are. There could be all kinds of other things that might be issues. There may even be little bits of cracks. If it's been on the track, could have had some abuse, so let's sort that out. But I think the evidence of being on the track are in the pads here. You can see, if I actually hold that to the camera there, you can see it's very, very thin. Compared to, in fact, it's unevenly thin compared to the other, or the new pad. So it's, again, definitely worth changing these because, again, I'm here, it's not that hard to do, and of course it means that the car might actually stop in the future when he's back on the track. Now when it comes to the rears, again, same sort of story. You can see that there's, you know, the sort of pitting and rusting that goes on that might actually fail an MOT, but again, obviously the disc itself is okay. There's no lips or anything on there. And again, if we compare that with a new one, you can see that, again, there's no difference in the thickness at all. So it's got loads of miles in it, but I'm just going to change them anyway, because again, as I said, I don't know how warped they are, if at all, because of all the mad driving that's been going on. And if we then look at the pads, again, they're sort of, I'd say, sort of slightly uneven wear. If you look at these two together, again, you can sort of see that actually, well, this one is definitely much, much thinner than it wants to be. And in fact, actually, the rears are probably worse condition than the front. So I'll change those as well, and then it will be tickety-boo. Right then, so now all the brakes are done, which is brilliant. So the last thing I need to do, I've been following the manual, but I can do this through tronic, is basically just reset the EPB. So I'm just going to go down to the bottom button there. My broken doesn't fix it, and then we should hear a little noise. Brilliant, in fact 2 little noises, because of course now they've wound them back in. So now the handbrake is back in position, all the brakes are in position. I have to pop the wheels on and go for a fantastic test drive. Not too racy. So some simple unused parts could have caused a failed MOT, and this simple service job couldn't be fixed at home or in a garage without the correct software and cables. But thanks to tronic, you can solve the next generation of automotive problems like a Bosch.